Implicit differentiation is kind of like taking each side of the equation as two variables, or separating the variables in each side of the equation and treating one of the variables as a function of other. So what do I mean by that? For example, let's say if we have a problem that is given as this, which is x squared plus y squared equals 1, right? Then we need to find dy over dx. We know that this is an equation of a circle, right? And but dy over dx is a way of finding slope. So how do we find how do we use this equation to find implicit differentiation? Well, like our definition said, let's treat one as a function of another. In this case, we can treat y as a function of x, right? So that means y equals f of x. And so if we have x squared plus y squared equals 1, and we can differentiate with respect to x, so that will give us d over dx of x squared plus y squared equals d over dx of 1. And we know different derivative of a constant is 0, right? This is going to be 0. So that means we can only look at whatever we have in our left hand side. So let me get rid of this, and then we can write here. All right. So that means what we can do is d over dx of x squared plus d over dx of y squared equals 0, right? So that means we can find the derivative of x squared with respect to x. So that is going to be 2x plus dy squared over dy and dy over dx. And if you noticed, we are using chain rule here. Okay. And that is going to be equal to 0. So 2x plus 2y times dy over dx equals 0. So now we have 2x plus 2y times dy over dx equals 0. How do you find dy over dx? Well, this is simple algebra. What we can do is maybe we can say 2x negative 2x equals 2y dy over dx, correct? Then so dy over dx equals negative 2x over 2y, which is equal to negative x over y, right? So the final answer is dy over dx equals negative x over y. So basically, what we just did here is we differentiated each side of an equation, right? We differentiated each side of an equation with two variables, x and y, and we treated one of the variables as a function of another, right? So that means dy over dx for this kind of equation is x negative x over y. So one thing to notice in this type of differentiation is to say we have another type of problem that says, okay, x to the power cubed plus 2xy equals maybe 5, right? So how do we solve this type of problem? Well, from a top level, like from higher level perspective, what we can say is, like we just did before, we can say d over dx of everything, right, equals d over dx of 5. Then we start slowly begin building our steps from here. So for quick demonstration, this will be so 3x squared plus so this will be 2 times d over dx of xy equals 0. And here notice that y is not constant because we are dealing with implicitly, right? If this was not implicit, it would be constant, and we can just consider it as a constant. But here you could use product rule. Okay, so let's look at another problem. It's kind of related to implicit differentiation, but it's more about application. How do we apply implicit differentiation in related rates, right? So given that x squared plus y squared equals 25, and we're also given dy over dx equals 7. We need to find dy over dx when x equals 3, right? So there is a kind of relation. Let's draw a table that says, so x equals 3, we are given, and dx over, so dx over dt, right? Okay, so this is supposed to be dt. Dx over dt is 7, and so we need to find y, and dy over dt. So like we did earlier, what we can do is, so in this case, because we're given the value of x, we can substitute that. So 3 squared plus y squared equals 25. Y squared equals 25 minus 9. That will give us 16. Y squared equals 4 squared. So that means y is going to be plus and minus 4, right? So we have two values of y. So then what is the value of dy over dt? Well, for this, what you can do is, so you can say d over dt of the given equation, x squared plus y squared, and d over dt of 25. And notice that we used implicit differentiation here. So I'm just going to write ID for implicit differentiation. So we differentiated the given equation with respect to time, which is dt, right? So that will be dx squared over dt plus dy squared over dt equals 0, right? Because this is a constant and the derivative of a constant is 0. Then what we can do is, notice that the denominator is with respect to time, the numerator is x squared, right? So that means we have to apply our knowledge from chain rule to find derivative. So that will be equal to dx squared over dx times dx over dt plus dy over y squared over dy times dy over dt equals 0. And just for a recall, so chain rule is for so if we have dA squared over dB, what you can do is you can write dA squared over dA times dA over dB, right? So this is a kind of recipe for this. And let's copy this. And we can start from here, continue from here. So that means, so we can look at this expression one by one, right? So this will be equal to 2x, and this will be equal to 2y. So also, if you notice, we're given the value of dx over dt, right, which is this. The value given in the problem is 7. So we can say 2x times 7 plus 2y times dy over dt equals 0, right? And we can simplify this further as 14x plus 2y dy over dt equals 0. And Also, what we can do next is, okay, now we are given, let's do, so 14 times, because x equals 3 is given, right? So the given as x equals 3. From here, value of x is given as 3, so we can put that value. So 14 times 3 plus 2y times dy over dt equals 0. So 14 times 3 is 42 equals, so I'm going to write negative 42, so I can write positive 2y times dy over dt. And we can cancel 42 by 2 for 21 times. So that will be, so negative 21 equals y times dy over dt, right? And when y is, because we have value for y to be positive and negative 4, right? So when x or y is positive 4, so that would be dy over dt equals negative 21 divided by 4. And how do I get this? Well, if we simplify this, it will be dy over dt equals negative 21 over y, right? If we have positive value for y, which is 4, positive 4, the value for dy over dt will be negative 21 over 4. Similarly, when y equals negative 4, what happens is, so we can write dy over dt equals negative 21 divided by negative 4. So that will give us positive value for dy over dt, which is 21 over 4. Okay. So this is our value, negative value, and this is our positive value. So finally, maybe in one line, we can say, well, the value for dy over dt equals plus and minus 21 over 4. Okay. So that is about finding rates. So what are first derivative and second derivative, right? Actually, we have been doing this all the time without even realizing the topic, because it's so intuitive to say, okay, second derivative should be derivative of something, right? Actually, that is true. And first derivative is the derivative of a function. First derivative is the derivative of a function, and second derivative is the derivative of the first derivative of the same function. So what do I mean by that? Well, let's look at this simple problem. It says, um, so y equals x to the power 7 plus 3x to the power 5 plus x to the power 3 over 2, right? And the problem is asking us to find second derivative. So this is actually d squared y over dx squared. And just for a recall, so anytime we see something like, okay, so if y equals f of x is given as our function, so y prime, or saying f prime of x, or dy over dx means first derivative of the given function y equals f of x. Similarly, if we have y prime, y double prime, or f double prime of x, or d squared y over dx squared, also means second derivative. And in the notation, if we notice, it has a very unique form, right? D squared y and dx squared. Well, actually, this is, if you want to see this, so this is actually derivative, or d over dx of the first derivative, right? Which is d over dx of the function y. So if I expand this, so this is the first derivative. Whatever I have in the parentheses is the first derivative, and the derivative of the first derivative is d over dx. So if I compress them, or if I put them all together, it will be d squared y over dx squared. So this is how we write notation for second derivative. So anytime we see this expression in the problem, it says, or even in solution, it means second derivative. Okay, that's a quick recall. So we're given a function at y equals x to the power 7 plus 3x to the power 5 plus x to the power 3 over 2, and we need to find the second derivative of this problem. Well, so from even this explanation, we realize that even to find a second derivative, we need to find first derivative first, right? So let's do it. Y prime equals, so let's find the first derivative. Well, there's the shortcut, or the faster way of doing this will be, well, 7x to the power 6 plus 15x to the power 4 plus 3 over 2 x to the power, this will be 1 over 2. So if you want to see it, how I got this answer, uh, let's do it here. Okay, let's copy the expression here. And so if we want to see this, how we can get the answer, we can just write d over dx of each expression, which is x to the power 7 plus 3 d over dx of x to the power 5 plus d over dx of x to the power 3 over 2. So what did I just do here? Let's break it down. Okay, so first expression is x to the power 7, right? Second expression is 3x to the power 5, and 3 is constant, so I brought it in the front. So I'm only going to deal with x to the power 5. Then I have x to the power 3 over 2, which is over here. And also, one more thing to notice here is that I added d over dx to each expression. So it's kind of like distributive. Okay. So this will be, so if you recall, derivative formula d over dx of a to the power n, it would be, so n times a to the power n minus 1, right? So with this logic, if we have n equals 7, it will be, well, 7x to the power 6, and this will be 3 times 5x to the power 4, and plus 3 over 2, x to the power 3 over 2 minus 1. And this whole expression is actually 3 over 2 over 2, which is 1 over 2, right? And the final expression is 7x to the power 6 plus 15x to the power 4 plus 3 over 2 x to the power 1 half. So this is the first derivative. And to find the second derivative, what we do is simply find derivative of the first derivative. So this is going to be d over dx of the first expression, which is 7x to the power 6, and plus, I'm going to write the constant in the front and then deal with d over dx and x to the power 4, then plus 3 over 2. So d over dx, x to the power 1 half, right? And it will be, so 7 is constant, so I can say 7 times 6 x to the power 5 plus 15 times 4 x to the power 3, or x cubed, plus 3 over 2 times 1 over 2 x to the power negative 1 half. And how I got negative, it's actually 1 over 2 minus 1 is negative 1 half, right? So this is equal to 42x to the power 5, 42x to the power 5 plus 15 times 4 is 60, x to the power 3 plus 3 over 4 x to the power negative half, which is the answer for the second derivative. Okay, so this is how we find second derivative using the first from first derivative. Okay, all right. Let's look at another problem of optimization, how we can get best result given the constraints, given the constraint from a set of possible outcomes, right? And this is very practical problem, and we deal with this type of situation in real life a lot. So let's quickly look at this situation. So it says given a fixed perimeter of a rectangle and maximal area, find the dimension of the rectangle, right? And it doesn't give us any set of values like, okay, so we know a rectangle looks like this, right? We know a rectangle looks like this. It has x, shorter length x and y, and we know the area is a, and perimeter is 2 times length plus breadth, right? 2x plus y. So although it doesn't give us any constant, like okay, our length is 5 centimeter, breadth is 10 centimeter, sorry, breadth is 2 centimeter, but we need to optimize, we need to think logically to find the optimal solution. So how can we do this? Well, we know perimeter is 2 times x plus y, and area is x plus xy, right? Because area is length times breadth. So let's call it equation 1 and 2. So we can say 2x plus 2y equals p, right? It will give us, so 2y equals p minus 2x, and so we can say y equals p minus 2x over 2, which is the third equation. So if we have defined a side which is length in terms of perimeter, we can plug that value to another expression, which is area, right? We also know area equals xy. So we can get the value of y from equation 3. So we can say x times p minus 2x over 2, right? And then what you can do is x times p over 2 minus x. And so what you just did here is define area as a function of x equals, so we can say x times p over 2 minus x, right? And if we expand this further, what you can say is a of x equals negative x squared plus p over 2x. Okay, so we just define area as a function of x only, x and perimeter. Okay, fine. So how do you find the critical points? Well, critical points are, so we can equate the first derivative equals 0, which is negative 2x plus p over 2 to be 0. So solving this, we can get x equals p over 4, and let's call it equation number. So let's call it 4, and this is 5. Okay, so if we put 5 in 4, right? 5 in 4 means put this value in this equation. So what happens is area of p over 4 can be written as negative p squared over 16 plus p over 2 p over 4, right? And this is going to be negative p squared over 16 plus p squared over 8 equals negative p squared plus 2p squared over 16 equals p squared over 16. And so area is written as p squared over 16. So this is how we optimize. This is how we optimize the best value for length and breadth. Especially now we are left with only area and perimeter without even realizing the specific length and breadth, right? We can only think about total area and the perimeter to find the value of x and y, which is the sides of the rectangle. So this is how we do optimization problem. I hope it was helpful, and thank you so much.